Hello, let's see now how we could solve the fourth challenge from Flair on 2019 competition, which was called Dnschess. We get the description: some suspicious network traffic led us to this unauthorized chess program running on a Ubuntu desktop. This appears to be the work of cyberspace computer hackers. You will need to make the right moves to solve this one. Good luck. Okay, and in this challenge what we are getting is actually few files. We get the message, which I guess is the same information that we have on the page. We have a ChessAI shared object, ChessAI file, and capture pickup. And usually in such challenges I will start with the pickup file. So if I have a network traffic, I will start with analyzing what's inside this network traffic file. So I open it in Wireshark, and we can see we have a lot of what seems to be a DNS traffic. We have DNS query for some addresses like rook c3 c6, Game of Thrones Flair on com, and then we get a response, DNS response with, I guess, some kind of IP addresses. So we have the same address, and I guess we have a IP address that resolves to this name, and it's repeats. So the query and then a response with an address, a query and response with an address. So we can see it looks like from those addresses that we are querying, it looks like a game of chess. So rook moves from c3 to c6, and then knight from g1 to f3, and so on and so on. So it looks like a game of chess. That's, I guess, name of the challenge. But okay, we don't know how to actually analyze this information. We know that we have some DNS queries for some URLs and then responses. Okay, so apart from the pickup file, we also have binaries, and I open them in Ghidra. So we have the Chess UI application, and if we open it in Ghidra, we'll see that we can search for main. Okay, that's not the main. Maybe start. Where's the main function? Okay, maybe let's not search. Maybe let's just look. Oh, entry. Okay, we have an entry, and actually if we go to the actual entry point, we see that we have some GTK application, and actually you could I guess run it also under Windows if you have X server, and actually I have it locally, but for some reason currently it doesn't want to start. Actually during the competition I managed to run the application and try to see what's going on. Yeah, but I guess it's not really needed to analyze this competition. We can actually check also some strings. What if we find something interesting? There's some like Chess Blaster 3000, key press event, file, new game. So there are some strings that informs about what the game is doing. But we also have some kind of like response, get AI name, game over, you win. That might be interesting. Where is it used? So it's something here. I already have analyzed this binary, so I have like a win switch, I guess. That's from initial analysis. But we can also see where this function was called. There are a few places where we are calling this function. Yeah, so this looks like something that might be oh, okay, I call it forfeit. So it looks like the computer quits and you won. But if we analyze this further, there is nothing really anything that will give us flag here. So basically it's not a part of the competition to win this game of chess, which was actually my initial thought, that I will have to win with the computer for some reason. But yeah, it's not the case, and I guess it's good, because probably I won't win with the computer. But if we analyze this closely, we can see that this ChessAI.so file actually is being used. So the whole logic for the next move is actually in this ChessAI shared object file. And this chess UI only calls those methods. So let's just see what's there. I have two files. I think this one might be modified by me a little bit. Let's just see if that's the case. Yeah, it wasn't analyzed, so I think that's mine. So let's just open the other one. Okay, and if we check here, we'll have some function like get AI greeting, get AI name, get next move, but we also see some get host by name, which might result in those DNS queries that we saw in the pickup file. And we are interested in this get next move function. So actually, if we analyze this function is called from the chess UI with a like index, the name of the piece that is being moved, old position, new position, and it will return the result. And what's being done here is actually we convert the old and new position into a string and concatenate it with this Game of Thrones flare on com. And also we concatenate the name. So actually in those lines we are creating those like the URL rook, c3, c6, and then we append Game of Thrones flare on com. So we can see that we actually found the code that is responsible for generating at least those URLs. So let's see what's happening later. And then we get the host by name. So actually we get the IP address. And then there's some checks that the address is correct. So we got actually some response. And yeah, there are some additional checks for the bits from the third and second bytes in the IP address. And if that's the case, we'll just set some variable to 2. But if it's something different, then we will sleep for one, I guess, millisecond or second. I don't know what's the actual value in sleep, but okay, it's in second. But then we'll do some interesting stuff here. So we will take the first byte from the IP address and we will XOR something interesting, some interesting data. If we look here, there's some kind of bytes that looks some kind of encrypted, something interesting. We are doing something with this data and we are using the XOR operator, so it sounds that it might be a flag. So yeah, so we are doing that for one byte and the second byte, and then we concatenate the string results from those XOR operations. Yeah, so that sounds like something interesting to us. So basically, it looks like those addresses that we see in the file, actually the responses for the URLs are used, at least one of the bytes is used to decode some bytes in the binary. This interesting data, this one before interesting data. Okay, and actually, yeah, we can verify that, but by writing some script. So I have the script prepared, and my script looks like that. So I use this dpkeyt package to actually work with pickup file, and I have some helper function like integer to IP or parsing the DNS queries. We'll look into that in a moment. There's like this gets this interesting data that we see in the binary. So basically this returns those 30 bytes. Okay, and then we have some extraction from the bytes from the IP. I never know, there's like a different order of the bytes in this structure that is returned by get host by name. I never remember which one is which, so I have like a, you can see I tried different orders, but actually, yeah, this was correct one. So the third byte is like at the least significant in this structure. So we have those function, and yeah, there's like a decode. So basically decode is mimics the same function as here. So we have this conditions like here. So if the if the third byte, so B3, and second byte, so B2, those conditions are met, we will not use this address. So not all addresses in the file are used to decode. We'll just continue, and then if it doesn't match, we'll get the address. And then there's some printing and more printing, and then this is the actual XOR operation that we saw in here in those two lines, this one and the second one. Okay, and having that, just for the rest, I just join the characters and print the flag. And DNS queries actually is the main function to extract the DNS data. So let's look there. So it uses this package, and with this package we have really good way to actually get into the pickup file. So we just create a reader from the file that we the file name we pass. Then we convert it to Ethernet packages. So basically we need to go through all the stack of the frames as we see here. So we have a frame, we have Ethernet, maybe not the frame, but the the packages. So we have first the frame, then we have Ethernet 2 package, then there is IP protocol package, then user datagram, and then domain name system response. So basically we need to go down each layer until we get to the DNS layer. And this is what actually happened here. So we check if the type is different than 2048, which if we can see here, it would be, so IPv4, this is the type. So we exclude any other Ethernet packages. Then we extract the data. Then we check if the P is different 17. Let's see, what was that? Was that the port? 17. Do we have something 17 here? It looks like we don't have, but I guess it's the IP. UDP. Okay, so we are checking if it's UDP protocol. Okay, so P is proto. Then we extract the data from the UDP to UDP, and then we check the ports. Source port, destination port. If it's different than 53 DNS, then we continue. Then from that data, we create a DNS object, and then we check if the query is in DNS response, then we continue. If it's like different opcode DNS query, then we continue. So we basically exclude all the data that doesn't lead us to our query and response. And then if we go through all those checks, we can actually access DNS, because we know that this will be the valid DNS query and response that we are interested in. And then we just get an answer. So AN is an answer in DNS, and we iterate through, because there might be more than one answer actually. There might be more than one IP address that is being returned, and we unpack it and we just append to some structure, like a list, I guess it is, with addresses that will be returned at the end. And this list is used actually to in the decode method. So it's being passed as a parameter. The data is also being passed. I print some information at the bottom, and then just go through all the addresses and decode the data. So let's see if it will work. So It's a Python script, so we'll use Python, and yep. So if we run it, it printed the length, it printed, okay, some addresses. I guess that's the IP in the hex form. We can see actually what it is. So it's the third byte and the second byte, and this is the hex of the IP address. And yeah, it's being just like a helper method, and then at the end we get the flag. So it looks like you looked up Z at flareon.com. Okay, looks like that's our password for the fourth challenge. So I guess yeah, that was a bit maybe harder, but not so hard. So yeah, that's also very nice. It was nice challenge with using like a pickup Wireshark and some Ghidra static analysis. So overall, I really like this challenge. So I hope you also like my solution. So if you do, just like and subscribe. And if there's anything I could explain more, just let me know in the comments. And see you next time in the 5th solution for Flare on competition. Bye.